Welcome! In this series of videos, we will look at software add-ons for the PowerBasic Windows compiler. Today we will look again at using the MyLittleGrid custom grid without the use of SQL Tools or SQL Server to speed up your application development. This was our application at the end of the last video in this series. The application displays a list of staff within a fictional company. By merely keying in either all or part of the surname or forename and clicking the search button, we can search out information from our database. The purpose of this application is to provide a rapid prototyping tool. The database is in fact flat text files, and the configuration of the grid is also held in flat text files. This allows the definition of the grid to be held outside the application. In doing so, it gives you a great deal of flexibility. The columns in the grid can be moved around, without having to actually change the logic within the application itself. When the application runs, it loads a configuration definition file. This cdef configuration file defines the appearance and the functionality of our grid. Normally, when you write this kind of application, you would be expecting to have a database sitting behind the application in a traditional client-server arrangement. The data only being displayed in the grid, but being pulled from the database. The way we have set up this grid is to use a series of libraries. The key library used in this case is the PB generic cdef functions library. When this library is referenced, as far as the application is concerned, it thinks it's connecting to a SQL Server database. However, this library acts as a middleman between the application and the data, allowing the data to be held in a series of flat text files. Once our prototyping has been completed, and the definition of the requirement has now been established, we can comment out this library and comment back in the generic SQL functions library. This would allow us to use SQL Tools to connect to a SQL Server database. I created the PB generic cdef functions library to allow this code to be run and tested without the need for either a purchased SQL Tools license or Microsoft SQL Server. However, while this library does actually function, it is not nearly as performant as SQL Tools and a SQL Server database. Plus, it is entirely a single user system, ideal for prototyping, but not for production use. What we are going to do today is we're going to finish up some of the code to save changes to the grid to our flat text files, and also give us the ability to add new records to the existing files. As we already have an Add Item button on the toolbar of our application, the plan is that when this is clicked, we will add a new blank row to the top of our grid, allowing the user to then enter details. If we have a look at the toolbar library, we'll see there are a number of constants determined at the beginning of the code. We have an add ID constant, which is a value of 4001. This is what we'll need to actually look at to trigger the event when the button is clicked on. So if we have a look at the callback function, which is the event handler for our dialog. In the WM command section, this is where we want to put our new event. We have an event for clicking the search button, and we have an event for clicking the ID save. What we need to do now is to create a new event for the ID add. This toolbar button is treated like any other normal button as far as creating the event is concerned. So what we want to do is we want to insert a row to the very top of our grid. And in order to do that, we're going to be using a function within our PB MLG utilities library. This is a library I created to make handling my little grids that little bit easier. This new function takes a single parameter, which is the handle for our grid, which is grid1. This function makes it very easy to add a row to the top of the grid. It determines the size of the grid based on the existing getRowsInGrid function, and then the getColumnsInGrid. And then it tests to see if there is only a single line in the grid at the moment. If that is the case and the first column is actually empty, it just does a redim on the array that backends my little grid. Otherwise it increments the number of rows, and then it sends a message to the grid to insert a row before row number 1, and it then redims the grid. And all we need to do after that is effectively refresh the grid. So with this in place, it would add a blank row to the top of the grid. So let's try the code. Once we click on Add Item, we will see the new blank row is automatically inserted at the top of the grid. As the primary key for all our records will appear in the ID column, there is currently nothing in this column. So what I want to do is to populate that with a 0. This will indicate to our following process that will save the changes that this is a record which has not been entered into the backend database yet. So we'll set our row counter to row number 1. And we're going to use the function we've used before to set the value of our result column. It takes the usual parameters, the form handle, the grid handle, the tab handle, the grid handle itself, the row number, and the column we wish to write to. In this case, it's IDX ID. And we're populating that with a value of 0. And then all that we need to do to finish off is to refresh the grid to ensure that value is actually written in. Before we run our code, we'll need to declare this new long row variable. So if we try running the code now, we click the Add Item to add a new row to the top of our grid, and it has the value 0 in it. At the moment, these fields are not editable. We can click on them, but we cannot edit them. So we'll need to change the definition of our grid. We can perform this change to the configuration quite easily by running the cdef config exe. If we pick our application, our form, our grid, and our tab, in this case the data tab. If we search that out, we can see a list of all the columns displayed to the user in the grid, and the name of the fields for the backend data. If we have a look at the forename and the surname, we'll see that both of these columns are currently locked. If we untick these, untick the job title to allow the user to update all of these fields. The payroll field is not currently visible on the grid, but the city is, so we will untick that. Now all the fields should now be visible, so if we save that config file and exit our configuration utility, if we go into the cdef config folder, we will see that our file has now been updated at the very top. So if we copy that file, go back to our sample app and into its cdef config file and copy our new file in. So having updated the configuration for our sample app, if we now run our sample app again, we will now see that the forename is now editable, as is the surname, the IT department, the job title, and the city. So if we hit our add button again, we can now put in some new details. And having updated that information, we can hit the Save Changes button. Now at the moment, although we have clicked on the Save Changes and it has given us every indication that it has saved, if we come out of the app and back in again, we will see that the new information has not been added to the end of the file. This is because we have not yet completed the ability to save data to our grid for a new entry. So there's a little bit more work needing to be done. So if we have a look in the function which saves the changes. In this function, the code will step through every record in our grid to see if any record needs to be saved. So it's looking for the updated marker. If the updated marker on the grid indicates that the record needs to be updated, it's calling the save record function to save that individual row to our database. And it gets back from that function a number. Currently we're using this as a true or false indicator. But what we want to do is to change this so that the result coming back from our save record is actually the record in the database which it is saved to, because we're adding a new record for which we don't know the record number, and the act of saving it will generate a record number. If we were writing to a SQL Server database, we would be using the identity setting to pull back the unique reference to that record. So if the value coming back is 0, it would mean we had not got back the record to which we had saved. And if we get back an actual record number, we must have successfully managed to update that database. If that were the case, there would be 3 things we'll need to do. One is to mark the record as being saved. The final thing would be to unmark the grid to remove the green highlighting on the record to indicate that it requires to be saved. And the final thing we need to do is to update the actual record number itself. We can do that quite easily using one of the My Little Grid functions, MLG put, which will take the record number and write it to our first column. So having done that, we now have to look at this save record function. This is a function that saves an individual record to the database. Most of this function is going to be unchanged. The only change we need to make to this function is at the tail end of it. At the bottom of the function is the part where our database is updated. So this will either be our flat text file or our SQL Server database. And currently we're using the run SQL function. The run SQL function only brings back a true or a false, which is fine if we don't need to get back an updated record number. However, we need to get that back now so that we can actually display that on the grid. I'm going to change from using the run SQL function to use the get generic data function, which is designed to bring back information. And we'll also amend the parameters, because one of the parameters we need to give it is an array to hold the information that's coming back. And assuming we do actually get a true coming back for running the entire function, the return to our calling function will be the value held in the first cell of our array, which will be the record number. And from here we can click on the Add item on the toolbar, which allows us to enter the new record. And clicking the Save Changes button allows us to save the change. We've got back a record number, 2001, which is a good indication that our record has indeed been saved. So if we do a quick query on it, we get back the new record. Now it's showing a highlighted skills field, which indicates that that field needs to be saved. Now this is a bug in the program because our cursor was left on the skills field, and it has inadvertently picked up the event to trigger an update. If we attempted to do another search, it would tell us of unsaved changes, so this field is obviously sitting as being updated. So one final change we want to make is to fix this bug. Let's have a look at the code. In the section of the event handler, the callback function, where we do the search, we're initially testing to ensure there are no unsaved changes before we let the user proceed. So at this point in the code, every record in the grid must be set as saved. So the last thing in this section of the code is to set the state of the Save toolbar button to being disabled, to indicate that all records on the screen are currently in the save condition. So what we'll want to do here is to put an extra piece of code in to ensure that that is indeed the case. And there is a function within our My Little Grid utilities to perform that exact function. It's called Mark Whole Grid as Saved. So having marked the whole grid as saved, we'll now want to do a grid refresh. And this should complete our changes. Let's try running the code again now. So if we click our Add Item, add our newer person in, and click the Save Changes. Now if we query that to see if this record has indeed reached a database, which it would indicate that it has, and click Search again, and there we are. We have cleared any outstanding flags and we can now do multiple searches quite happily. So in summary, we have now taken our grid through to the point of being able to display information, to allow the user to search selected information from it. We can add new records or update existing records, all without having a SQL Server database at the back end. We can change the column positions around using the cdef utility. And this now gives you a quick facility by which you can do a proof of concept on any utility that is designed to query databases and display the information in a grid. But that's it for today. Thank you for watching.